It's me, Shailendra. Welcome you to Monastic online classes. Today, from class 10 OPT Math, we will start the first lesson, that is function. And we will learn some important definitions and theoretical part of it. First, starting with, in function, you have already completed this exercise in class 9. Basic things, you have completed it in class 9. In class 10, we will start this exercise with few more further types of function. That is starting with algebraic function. What is an algebraic function? Simply we can say a function in which algebraic expression is involved. A function in which algebraic expression is involved is called an algebraic function. If you go in further in detail, we can define it a function consisting of finite number of terms, involving powers and roots of the independent variable, and the four fundamental operations plus, minus, multiply and divide is called an algebraic function. If we go through the example, we can take a function like this, 3x plus 5. That's an algebraic function. You can write f of x equal 2x by 3x plus 5. That's also an algebraic function. Linear function now. This linear function is an algebraic function in which degree is 1. So we can define an algebraic function of degree 1 is called a linear function. An algebraic function of degree 1 is called a linear function. In this example, what you can see, here it's an algebraic function and its maximum power of variable is 1. So that's the example of a linear function. To be a linear, it must be an algebraic. Then it is quadratic function. An algebraic function of degree 2 is called a quadratic function. We have 2x squared plus 3x plus 5. Here, maximum power of variable is 2. So that's an example of quadratic function. Then we have cubic function. Again, same as earlier one. In linear, degree was 1. In quadratic, degree was 2. Now in cubic, degree is 3. An algebraic function of degree 3 is called a cubic function. We can go through an example. That is 3x cubed plus 4x squared minus 5x plus 2. Here what you can see, maximum power of the variable is 3. That is degree of this algebraic expression is 3. So that's an example of cubic function. Constant function, a function in the form of fx equals c. F of x equal x is identity function. Here we are in constant. F of x is equal to c. Example is f of x is equal to 5. It means whatever we put the value of x, result must be 5. That will be the constant function. Identity function, a function in the form of f of x equal x. If we go through the mapping diagram, if it's a function what you can see in this function, image of 1 is 1, image of 2 is 2, image of 3 is 3. Image and pre-image are exactly the same in all these conditions. Such type of function is identity function in which f of x is equal to x. Transcendental function, the function which is not an algebraic function, is called a transcendental function. Suppose that in all we have used the variables, that's an algebraic function, but instead of that, if I use 10x, now it's not an algebraic function, so it's a transcendental function. In class 10 we don't require this thing, but if it is log x, it's not an algebraic function, so it's a transcendental function. Trigonometric function, a function in which trigonometric ratios are involved, is called a trigonometric function. Okay, here in this function, one of the trigonometric ratios is involved, so this is an example of a trigonometric function. In trigonometric function, we have to know few more things. Before that, it is periodic function. A function f is said to be a periodic function if there exists a positive number t independent of x, such that f of t plus x equal to f of x for all x belongs to the domain of f. Go through the example. Sine 180 plus theta. You know that cos 180 360 plus theta is cos theta. The here cos 360 plus theta is cos theta. And now if you change this value, whatever the value if you put, that will not change. It means if I write the function like f theta equal cos 360 plus theta, that will always be cos theta. So that's the example of periodic function. And in this 360 is the periodic function and 360 is the period. The period of the function is the least positive value. Here, that is the 360. Least positive value of t independent of x, for which f of t plus x is f of x for every x belongs to domain f. Then t is called period of f of x. Here we have taken a periodic function in which 360 is the period. In trigonometric function, we can define the period in another way also. That is the distance required for the function to complete one full cycle. When you draw the graph of sine function, cosine function like that, you will got this type of cycle. So when we got this type of cycle, if such type of cycle is completed, then the distance required for the function to complete one full cycle is called the period of the trigonometric function. Then amplitude of the function is the value of the function to its maximum or minimum. So what is the maximum height or minimum height they can get? That is called amplitude of trigonometric function. In trigonometric function, you have to remember this chart. Nowadays, 1 mark question is also asked, and these things can be asked frequently. In sine function, domain is minus infinity to infinity. Range is -1 to 1. What's the meaning of this type of interval? That is called interval. That is open interval. That is, when we say closed and open, closed means the values are lying between them. -1 and 1 is written inside this. When we use this sign, it means -1 is also included there and 1 is also included there. If we use this sign, it means -infinity and infinity are not there. Only those values between these two value lies, but these two value doesn't lies. Then we will use big bracket. When it lies between these two value also lies. If not, then we will use the small bracket. That is closed and that is open. Closed interval and open interval. Maximum value of sine function is 1. Minimum value is -1. Period is 2 pi. X-intercept is there. Y-intercept is there. What is X-intercept? What is Y-intercept? If you put X value 0, what's the value you will get? The value of Y is Y-intercept. If you got Y equal to 0, what's the value of X you got? That is the X-intercept. You have to remember these things first. These all things will be required in the first exercise. Tomorrow we will discuss about the 1 mark question. Now we are going to the important things in this exercise. We have to learn 3 important things in the function. First one is composite function. Before going to definition, we understood the meaning of this with example. You can see f of x is 2x plus 5. If we substitute the value of x with 5, what will be the change there in x then? Wherever there is x, we have to substitute is with it 5. 10 plus 5, that is 15. That is f of 5 is 15. Same way, if I substitute this value x with x plus 2, wherever there is x, we have to write x plus 2. That is 2x plus 4 plus 5. That is 2x plus 9. Same way, if you replace the value of x, this value will be changed. Now when we have more than one function and we have to combine these two functions, one function is f of x, another is g of x, and we have to find the composite of that. We will use this sign. We will read it as f circle g of x. F circle g of x. We can use f of g of x. It means we have to write in this way. We can say g is followed by f. First of all, you have to write inside the bracket, and you have to do first, that is the function g of x. What's the value of g of x? Look up, that is value is 3x minus 2. Now you have to put this value in function f. We have the function 2x plus 5. Now you have to write 2 times 3x minus 2 plus 5. That is 6x minus 4 plus 5. That is 6x plus 1. If we have to find g circle f x, we will write g bracket f bracket x. Now first of all, we have to write the value of f of x, that is 2x plus 5. Substitute this value in g. You have the g value 3x minus 2. In place of x, now we have to write 2x plus 5, 2x plus 5 minus 2. That is 6x plus 15 minus 2. That is 6x plus 13. Go with more example. If we take f of x equal x plus 2 and g of x equal 2x plus 5, and you have to find g of fx. We can write this in this way, then substituting the value of f of x, that is x plus 2. Now put this value in function g of x, 2 times x plus 2 plus 5. That is 2x plus 4 plus 5. That is 2x plus 9. Same way, if we have to find f of g of x, that is f of g of x. Gx value is 2x plus 5. We have to substitute this value into f. Here f is x plus 2. In place of x, we can write 2x plus 5. Now it came 2x plus 7. That's our result. Or you, if fx equal 2x minus 3 and gx equal 4x plus 5, find the values of f circle gx and g circle x. If f of x equal 3x minus 4, g of x equal 4x plus 5, and h of x equal minus 2x plus 7, then find the values of f circle gx, g circle hx, and circle x. If we go further on this, f of x is given 3x plus 4, h of x is given 2x minus 3, and we have to find f of f circle h2. we can write in the same way as earlier we have done. Now, in place of x there is 2. So, in h of x, it is 2x minus 3. In place of x, we can write 2. Now, 4 minus 3 became 1. Now, put the value 1 in f. 3 into 1 plus 4. 3 plus 4 is equal to 7. If you have to find h of f minus 3, we have to put x equal minus 3 in function f, that is 3 multiplied minus 3 plus 4, minus 9 plus 4, it came minus 5. Now put this value in function h, 2 into minus 5 minus 3, minus 10 minus 3, it came minus 30. Minus 2x plus 7. Find values of h, circle g minus 4, g circle h 2. F of x equal 3x minus 4, g of x equal x square plus 5, and h of x equal minus 2x plus 1. Then find the values of f circle g minus 2, g circle h minus 3, and g circle f 2. So you have learned how to find the composite function. Again, going further, if there are more than 2 functions, f of x is 3x plus 4, g of x is 2x plus 5, h of x is minus 2x plus 1, and we have to find f circle g circle h. Either it is written, circle is given or not. Either it is written in this way, either it is written in this way. All these are same. F circle G circle H. First of all, we will write it inside the bracket, and at last we will add the variable also. So we have the function h of x is minus 2x plus 1. This value you have to put in function g of x, that is 2x plus 5. 2x plus 5 you can put, that is 2, and in place of x, minus 2x plus 1 plus 5. Do the multiply. Minus 4x plus 2 plus 5, it came minus 4x plus 7. Now you have to substitute this value into f, that is 3 times, in place of x, minus 4x plus 7, minus plus 4 is also there, minus 12x plus 21 plus 4, that is minus 12x plus 25. If it is written in different order. G circle F circle F. Same thing we have to do. First write inside the bracket G H F of x is 3x plus 4. Now what we have to do? We have to put this value in h. H is minus 2x plus 1. So write minus 2, 3x plus 4 plus 1. It became minus 6x minus 8 plus 1. Do the sum. Now you have to put this value into this. That is g of x is 2 times minus 6x minus 7 plus 5 minus 12x minus 14 plus 5 minus 12x minus 9. Now for the homework, you have f of x, x plus 3, g of x, 2x minus 5, and h of x, 3x plus 1. Then find the values of f circle g circle hx, g circle f circle hx, and h circle f circle g 2. That's the composite function. The definition of this composite function. If f is a mapping which map A into B and G maps B into C, then a new function from A to C is called a composite function. Of f and g. It is denoted by G circle F. We have completed now composite function. In this chapter, as I told you, we have three important things. First one is completed, that is composite function. Second one is inverse function. One thing we have to remember, if that's an composite function, if question asks what is the domain of f circle gx, what is the domain of f circle gx? If we write the question like this, your answer is domain will be the last one. Answer will be domain of g of x. What is the range of f circle gx? Answer is the range will be range of f. It means it is f circle g, so g function domain will be the domain of this composite function, and range will be the range of f. Now we have composite function. After that, inverse function. For inverse function, function must be 1 to 1 onto. If f is an 1 to 1 onto function, from A to B, then a new function from B to A is called an inverse function of function f. It is denoted by you can write f inverse only. To be an inverse function, function must be 1 to 1 onto. And if we exchange it, domain became range and range became domain, then a new function formed, that is inverse function. How to find the inverse function of a function? If a function is given and we have to find the inverse function of this, so we will do always, we will suppose image as y, then interchanging the role or position when we say interchanging the position or role, it means where there is y, instead of that we will write now x. Not required for function this is equal to y. Now in place of x we have to write y. And we want to find the value of y. So we can write 2y is equal to x minus 3, or y is equal to x minus 3 by 2. Whatever the value of y came, that's inverse function. That's the result we got. That's the way to find out the inverse function. Look another example. If a function is given f of x is 5x minus 4, and we have to find the inverse. Starting it with y equal f of x equal 5x minus 4. We have to interchanging the role of x and y x equal 5y minus 4 x plus 4 x plus 4 by 5. That's it. We have inverse. In the same way, when already the inverse function is given, if f inverse 3x minus 5y 7, then find f of x. We will do exactly the same thing. We will suppose y as the image of f inverse of x. Exactly the same thing we will do, interchanging the role of x and y. In place of y we can write x, and in place of x we can write y. Do the simplify and find the value of y. Change the side. Value of y, whatever came, that's the inverse of inverse. Therefore, f of x is 7x plus 5 by 3. Now you have some your work. Find the inverse of the following function. Then, if f inverse x is 2x minus 7, then find f of x. If 2x plus 5, then find f. That's it for today's class.